So, for those of you that are going on to Algebra 2 honors next year, one of the things that I wanted to get you a little bit of pre-learning on is the unit circle. Now, the unit circle is the major focus of trig as you move on with your mathematical career past geometry. So, we have to first review things that you already know. Remember that when we're doing a trig unit and we had an equilateral triangle, we could drop an altitude from any one of the vertices. It would bisect the opposite side and bisect the angle that it went through. Since this triangle was initially an isosceles triangle, each half, when that altitude is dropped, it was cut into an exact 30, 60, 90 triangle. And the pattern was that the hypotenuse, which is one of the lengths of the full side of the original isosceles triangle, has a length of 2x. When we dropped the altitude, it cut that side into two equal parts. And then we could use Pythagorean theorem and get x radical 3 for the height. And then we used sine, cosine, tangent ratios to write the ratio opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, leading to the sine of 30 and the sine of 60 being the same values, opposite order, as cosine 60 and cosine 30. And then when we did opposite over adjacent for the 30-degree angle, it was radical 3 over 3 after we rationalized the denominator. And then when we did it opposite over adjacent for the 60-degree angle, it was radical 3. Then we went and looked at a square, although I think we actually looked at the square first when we did this, but the square creates an isosceles right triangle. So in the isosceles right triangle, the equal base angles would each be 45 degrees, and with both legs being the same length, we did Pythagorean theorem and realized that the hypotenuse is always radical 2 times greater than whatever the side length is for a 45-45 right triangle. That led to a sine value opposite over hypotenuse. Rationalize the denominator being the same as the cosine, radical 2 over 2 for both of those, and then the tangent was 1. So we're going to explore a little bit more other exact angles, and we're going to take it a step further. So the unit circle is called the unit circle because all circles are similar. What we do is we simplify all circles created by a scale factor down to a simple radius of 1, because every other circle that has a radius bigger or smaller than 1 is just a scale factor size different, but all the angles would be, all the central angles created would be equal, create equal ratios. So what I'm going to do is use a scale of 0.25. So 0.25, 0.5, 0.75, and then finally 1. 1. This is just so I can have a little bit more space to make my circle. And there's my circle. So my circle has a radius of 1. So what we're going to do is look at the coordinates of the points that are on this circle. So starting with our x-intercept and the positive x direction, because our radius is 1, that has a point of 1, 0. Next, the y-intercept, if we go around in our positive clockwise rotation direction, that's the direction of the quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. So then the y-intercept has a coordinate point as x is 0, y is 1. And the other x-intercept on the left, x is -1, y is 0. And then down here, the other y-intercept, x is 0, y is -1. So because our radius is 1, our 4 intercepts are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. The angles of 30 degrees, 45 degrees, and 60 degrees use our exact values to help us figure out the coordinates of the point on the unit circle. So, for example, if I estimate a 30-degree angle, something like that, the angle is always measured from the x-axis, always from the x-axis. Whether it's x-axis up or from the x-axis down, you always measure the angle from the x-axis. What I'm going to do, I estimated a 30-degree angle. I'm going to drop an altitude here to create a right triangle. So what I'm looking for are the coordinates of the point on the unit circle with a radius of 1. That means my hypotenuse is 1. And I want to find the x-coordinate and the y-coordinate of that point. So we can use trig to find the x and the y, because the length of the side adjacent to the 30-degree angle, that would be the distance along the x-axis, the adjacent side, because I know the hypotenuse, if I take the cosine of 30 degrees, the angle that I estimated, I know that it is adjacent over hypotenuse, and our hypotenuse is 1, because that's the radius. From our exact values, I know that the cosine of 30 is radical 3 over 2. So the length of my adjacent side is radical 3 over 2. The length of that adjacent side would be the distance from the origin to the x-coordinate to give me that point. Now, if I do a similar calculation with the sine of 30, sine of 30 would be the opposite side over the hypotenuse. The sine of 30, according to the table of the exact values we know, is 1/2. And the opposite side would be a length of 1/2. That gives me the y-coordinate. So what we're seeing here is the exact value for 30 degrees for sine is the y-coordinate off the unit circle. And the x value of that point is the cosine. So going around this unit circle, I can continue this with every point on the unit circle. What happens is the sine value of the angle gives me the y-coordinate of the point, and the cosine value of that angle gives me the x-coordinate. Cosine is x, sine is y, alphabetical order. C comes before S, x comes before y. Now what we have done so far is just looked at acute angles, 30, 45, and 60. But notice our circle does a full 360 degrees. So we have to look at some other angles besides just those few basic ones. So the 30-degree angle we just talked about had a sine value, which is our y-coordinate, of 1/2, and a cosine value, which is our x-coordinate, of radical 3 over 2. At 45 degrees, because we would drop an altitude or a height that is equal to the base, they would both be the same value, radical 2 over 2, as we discussed on the first page. And when we get to 60 degrees, just like in the table, the coordinates from 30 degrees swap. So then what happens if we keep going? Well, what happens is we get to 90 degrees. So measured from the positive x-axis up to the y-axis, we get a 90-degree angle. And we already talked about how the coordinates at that point would be an x value of 0 and a y value of 1. This means that the cosine of 90 degrees is 0. That's the x-coordinate. And the sine of 90 degrees is the y-coordinate, would be 1. Now some fun and cool things happen as we go around the circle and stick with our multiples of 30 and 45. As we go around the circle, we first had our 30-degree angle, which had a y-coordinate of 1/2 and an x-coordinate of radical 3 over 2. At 45 degrees, it was radical 2 over 2 for both x and y. For 60 degrees, it took our 30-degree coordinates and swapped the order. And then up at 90 degrees, we had x value of 0 and a y value of 1 because our radius is 1. As we keep going, remember that I said that our angle is always measured from the x-axis. So going around our circle, the next coordinate point that we come to, measured from the x-axis, is actually 60 degrees up from the x-axis. But instead of being in quadrant 1, where sine and cosine, which means x and y, are both positive, in quadrant 2, I know that the x's are negative. But if I'm 60 degrees off the x-axis, that means I'm going to have the same coordinate points as 60 degrees off the x-axis in any direction. So my 60-degree coordinates in quadrant 1 match the 60-degree coordinates from quadrant 2, so the x is 1/2 and the y is radical 3 over 2. But now I have to make the adjustment that I'm in the second quadrant where x's are negative. Now, I can't have two different numbers for 60 degrees. The 60-degree angle that is in quadrant 2 is called a reference angle. It refers to how far the terminal side of my angle is from the x-axis. Okay, so there's a new vocab word there, terminal side. What I mean by terminal side is the side that helps create the angle. When we're talking about the angles, we are always measuring from the positive x-axis. The reference angle will go from the nearest x-axis, but the major angle measure, the main angle measure, is measured from the positive x-axis. So what I'm saying here is we had 30 degrees up from the x-axis, then 45 degrees up from the x-axis, then 60 degrees up from the x-axis, then 90 degrees up from the x-axis. And as we keep going, where we're at now is 120 degrees. 120-degree angle measured from the positive x-axis. So from the positive x-axis, the last point we just created is a full angle of 120 degrees, because what we've done is gone 30 degrees past 90. Now, if we keep going around the circle, what we're going to see is the pattern of the coordinate points will be changed depending on the quadrant. So, for our next angle, which would be 135 degrees from the positive x-axis, and 135 degrees from the positive x-axis would be a reference angle of 45 degrees from the closest x-axis. So from the positive x-axis to the next point we're filling in, we have a 135-degree angle, but that 135-degree angle has a reference angle of 45 degrees because they both lead to the same terminal side. So the coordinates will use the same numbers as our 45-degree coordinates, but we have to make an adjustment for the fact that they're in the second quadrant, so it's negative x value. And then as we keep going around the unit circle, we would keep using the same points, same coordinates, just make the appropriate adjustment depending on the quadrant we are in. So that means for my next angle, the coordinates would be radical 3 over 2, negative, because it's in quadrant 2, and then positive 1/2 for the y value. The angle measure from the positive x-axis to that terminal side where the angle would stop would be 150 degrees, because I am 30 degrees shy of the nearest x-axis. So as we keep going, we already had 180 degrees labeled where x is -1 and y is 0. And we basically just keep going around the circle and get this whole thing filled in with all the exact coordinate points. So a 30-degree angle away from the x-axis uses the coordinates radical 3 over 2 for the x value and 1/2 for the y value. Now that we're in quadrant 3, x and y are both negative, make the adjustment in the coordinate points. So at 225 degrees, they're both negative, radical 2 over 2, negative radical 2 over 2. And then at 240 degrees, negative 1/2, negative radical 3 over 2. And then we're at 0, -1 at 270 degrees. And then as we keep going, remember that starting at 0, and then full circle would go to 360 degrees. Now we are 60 degrees away from 360. So then this would be 300 degrees. But we use our reference angle of 60 degrees. And now we are in quadrant 4. The x coordinates are back to being positive, but the y coordinates are negative. So the x coordinates are positive, y coordinates are negative. X coordinates are positive, y coordinates are negative. And we started out with an x value of 1 and a y value of 0. And we get back to an x value of 1 and a y value of 0 at 360. So that's the unit circle. That's the idea. So these exact values that I had you memorize is going to expand greatly next year when you start doing trig. And you will be expected to have all of these memorized in both radians and degrees. So this year, I just needed you to memorize the sine of 30 is 1/2. Cosine of 45 is radical 2 over 2. That focuses on quadrant 1. It's those same numbers, just adjusted for positive or negative, that fill in the whole rest of the circle all the way back to 360. So next year, you're going to be asked, what is the exact value for the sine of 150? Or what is the exact value for cosine of 300? And then you're also going to get into the exact values for the tangents of all these as well. What I have for you, and it should be in part of the document, is all the coordinates that we just talked about labeled around the unit circle with the degree measure marked at each one and the radian equivalent marked at each one. This is going to be a good reference for you to help you start off next year, but these are things that you're going to have memorized. So enjoy your summer, good luck, and I'll see you sometime.